Hello future engineers, welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends. That's one way you can keep me going, inspired and refreshed. Now if you find my videos interesting and important to your studies, also please don't forget to subscribe. So here is a problem on steel force resolution, but this time with respect to tangential and normal components. So resolve each of the forces shown into normal and tangential components. Also express F1 in vector form in terms of its tangential and normal components. Express F1 also in rectangular vector form. The magnitude of F1 is 320 newtons while that of F2 446.8 newtons. F3 has a magnitude of 188.6 newtons. So uh, I will leave F3 to you to express it in terms of its tangential and normal components. I'll just present F1, its normal and tangential and normal components, rectangular vector components, and for F2, just the tangential and normal components. Then for your part, I want you to express F3 in terms of its tangential and normal components. So here's the figure, and this is F1. F1 has a slope of 15 vertical, 8 horizontal. The inclined plane where this crate or body acts with gravity force F2 is making an angle of 25 degrees with the horizontal or with the positive x-axis. So for the solution for F1, so this would be the tangential axis, normal axis. The tangential axis makes with a positive x-axis of 25 degrees. Therefore, the normal axis, which is perpendicular to the tangential axis, makes an angle of 25 degrees with the y-axis, positive y-axis. So let's have superimpose F1 320, the hypotenuse. Then this angle is arctan of 15 over 8 with the horizontal. So that is 61.928 degrees. Therefore, the angle that F1 makes with the tangential axis, the measure of this angle is 61.928 minus 25 degrees. So drawing the rectangle through the tips, take note that this is F1 tangential, which is directed towards the positive tangential axis, and this measure is equal to this angle here, 61.928 minus 25. So I just put it there so that it will not be unpleasing to the eyes. So this is also 96.928, and this is F1T, F2T. Both F1T and F1N are positive. They are directed towards their positive directions, respectively. So F1T is 320 cosine of this angle, and the angle is 36.928. So F1T is 320 cosine of 36.928 degrees, and that is equal to 255.8 newtons, while F1 normal is, which is equal to this, is from this right triangle, 320 sine of 36.928, because it is opposite of 36.928. So it is equal to 192.3 newtons. So expressing in vector form with E sub t, bold face, as unit tangential component, and E sub n, bold face, as unit normal component. So in vector form, 255.8 E sub t plus 192.3 E sub n newton. So that is F1 in vector form in terms of its tangential and normal components. In terms of rectangular components in vector form, F1 is 320 cosine of 61.928 degrees plus I plus 320 sine of 61.928 degrees J, where I and J are unit vectors in the direction of positive X and Y axes respectively. So F1 in rectangular vector form is 150.6 I plus 282.4 J newtons. Then for F2, which is a gravity force of magnitude 446.8, so we draw rectangle parallel and perpendicular to the tail and the tips parallel to the tangential and normal axis as shown. And remember that this is also 25 degrees. So this is F2T, which is opposite to the tangential axis, so it is negative. F2N is also opposite to the positive normal axis, so it is also expected negative, and the measure of this angle is 25 degrees. From the figure, F2T, which is equal to this, is expected negative, so it is magnitude negative 446.8 opposite to 25, so sine of 25. So F2T is negative 446.8 sine of 25 degrees, and it is equal to negative 188.8 newtons, while F2N is also negative, opposite to the positive N direction, is negative 446.8 cosine of 25. And it is equal to negative 404.9 newtons. Then, for your part, F3 show that F3 tangential is negative 142.3 newtons and F3 normal is equal to positive 123.7 newtons. So the tangential component is negative, the normal component is positive. So that's it for your part.